Okay, in this video, I will cover question 3 and I will cover question 4. Basically, it is your energy topic. So in the first question 3, you can see that there is a person pushing onto a wall and it exerts a force of 40 Newton on the wall and the wall didn't move. So if the wall didn't move, it would have zero kinetic energy, right? So now the question is asking you to find the work done by this boy on the wall. So you may want to ask yourself, what is work done? Basically, work done is the energy that is transferred to an object. So in this case, what they are saying is that they want you to find the work done on the wall, right? So they are asking you, can you please find the energy that is transferred to the wall? And they are saying that this energy is transferred by this boy. So if you think about this, although the boy is pushing onto the wall, the wall has actually 0 KE change, and the wall didn't actually rise in height. So there is no change in the gravitational potential energy as well. So therefore, is there any energy transfer to the wall? No, right? Because if there is energy transfer to the wall, then my KE and my GPE should change. The fact that the KE and the GPE didn't change means that there is no energy transfer to the wall. So therefore, I know work done is 0. Then you may ask me, teacher, how about if I use formula to solve? Well, when you use formula to solve, work done is given by the force multiplied by the parallel distance. Now, although the force acting on the wall is 0, but did the wall move? No, right? So therefore, the distance moved is 0. And any number multiplied by 0 will give you 0 joules. So that is why the work done on the wall is actually 0. Now for question 4, it is about how energy change from one form to another. And they are telling you that at the very beginning, that the card is at rest. So meaning that at A, is there any kinetic energy? No, KE will be 0, right? So the only energy that is at A will be your GPE, right? For me, when I'm doing a question, I like to put all the information that I can possibly found in the same diagram. So here, actually in the words, they actually tell you that the mass of the car is 200 kg. So I will just write it over here. So basically, when I look at this diagram, I know that as the car moves, they will have some KE, but I'm not interested in it. When the car comes to here, what type of energy do I have? Well, I can see that definitely there is going to be GPE as well, but maybe a smaller GPE because the height is different. It is definitely moving at B, so I will see that there is some form of kinetic energy. So I will know that, okay, basically it's like that. So in my mind, what I have now is that I would have this flowchart, GPE at A, this sum of energy is going to get converted into GPE at B, and at the same time, some of it is going to change into kinetic energy so that my card can move. So that's what I see just by looking at the question. So now part A, they are asking you to find GPE. You need to be able to recall the GPE formula. Are you able to? So GPE is basically your mgh. The mass is already given. G is you need to know. On Earth, it is 10. And in our case, our height is 12. So if you multiply all of them together, you should be able to get your answer. For your part B, principle of conservation of energy, basically you need to memorize its definition. So this, I leave it to you to go and find out. Okay, for your part C, they actually ask you to prove that the KE at B is 1004. So now if I organize what I have found, from part A I already know that GPE at A is 24,000. So down here, I would be able to know that this is 24,000 joules. Right, the question in C actually wants me to prove that the KE at B is 1004. I need to find this number, right? And I can see that, well, my GPE at A is going to get converted into the yellow energy and green energy, right? So I'm going to first write down my expression that describe the situation. Now, before I do that, I just want to warn that many of you, especially the weaker one, when you are asked to show kinetic energy, very quickly you will go and do something like that. KE, oh, KE is half mv square, I remember. And then you realize that you are stuck because the only number that you know is actually the mass of the card. Do you know the velocity? No, right? And you find that you will get stuck and then you will be like, oh no, how come I do not know how to use the formula? Unfortunately, that is not the case. You know how to use the formula, but you are too focused on the wrong thing. So in physics, it is very important for you to be able to write this, how one energy changes to another form in a mathematical way. So what do I mean by mathematical way? Well, just now in this diagram over here, I think I will write over here. Basically, if I want to turn this into mathematics, it will look something like that. GPE at A is equals to the GPE at B plus the kinetic energy at B. This is what I mean by the system expression. What does it mean? It means that it is an expression, this is called an expression, the yellow highlighted one, that actually describe what happened over here in terms of energy transfer. So once you have this, what you need to do is that you will take each of these terms, this is called terms, 1 term, 2 term, 3 term, and you are going to expand it downwards into its formula. So since GPE at A, we have already found the number, we can write the number directly. As for GPE at B, we do not know, but we know that GPE is given by this formula, and we should use the height at B, right? Now, if you look at your part C, we are only required to find the kinetic energy. So therefore, here I'm just going to put KE over here. Since we know that at B, my new height is 5, I can do a substitution over here. So just keep on developing it downward. This will be 200 bracket 10. My new height is 5. And you will be able to actually prove that your KE at B is indeed 14,000. Okay. Now let's move on to your question 5. Okay, question 5 shows a person with a certain mass. So like I said, I will always put all my things in one place. Okay, it is climbing up a stairs of 6 meters. So meaning that this height is 6 meters. And basically it takes 15 seconds to reach the top. So I am to find the work done by Ali. So what did Ali do? In summary, basically Ali did is, at the beginning, Ali is at the bottom. And then after some time, Ali is able to conquer the stairs. So, in terms of energy, what Ali did is that it has changed its GPE by this amount, right? So this GPE, right, has to come from somewhere. Where does this GPE come from? Ali cannot magically appear at a higher place, right? So this GPE has to be supplied by something, right? I have to supply energy externally so that Ali could gain this GPE and reach a new height. Now this energy that is supplied internally has a name. This name is called work done, right? Like I said, work done is just energy transfer, and this work done comes from none other than Ali, right? Ali has to use his muscle. He has to convert the chemical potential energy from the food he eat and transfer to his body so that his body can move from a low place to a high place, which involve this GPE. So actually down here, if you decided to quickly go and use F, force work done is equals to force times distance, you will ask yourself, what is the force and what is the distance, right? So you can see that in physics, it is sometimes not always uh, to rely on this formula. You will find that you can't. Sometimes when you apply a formula, you will see that, how come I cannot find the number for this particular parameter? Okay, some of you, when you are very focused in your formula, you ask, what's F? Right? And then you look at the number like, okay, anyhow, I take this F. Then you will find that, wrong. Then your teacher will tell you, how come you never study? But it's actually, you have studied because you have memorized the formula. But you are getting it wrong because after you applied the formula and you find that you are unable to find the correct parameter, you anyhow go and pick the number without asking yourself, is that F or is this M? Right? So you need to be able to check this, and you cannot like just forceful anyhow tin cai put like that. Okay? So down here, what I have given you is that the gain in GPE have to come from somewhere, and this energy that is being supplied to Ali must be the work done on Ali. Work done simply means energy transfer to Ali. So in this case, what you are supposed to write is to write down the expression, right? The work done by Ali must be responsible for the gain in GPE, right? So can you see that when you are doing your energy question, it is not so much about writing formulas, but to write the expression that describe what is happening. So in this case, this is what is happening, that the work done by Ali has been converted into the gain in GPE. So in this case, work done by Ali is what you want to find. GPE, turn it into mgh. So the mass of Ali is 50, G is 10, and you have moved 6 meters upward. So that's how you get your answer, 3000 joule. Okay, for your part B, this is like the last formula. To find the power, you take the energy divided by time. Now this energy that we are talking about is energy in general. It can be KE, it can be GPE, it can be work done. So since the word hence is given, it means that we have to use what we have gotten in the previous question. So in this case, it will be the 3000 that we have calculated divided by the time that this energy conversion has taken place, so which is 15. So that's how you get your power over here. Okay, so in this video, just a summary, what you have learned is that, of course, you now know that basically it is not so much about just memorizing the formula and apply. You should interpret the diagram, interpret it in terms of how the energy move from one place to another or converted to one form or another form. From this understanding, you should be able to write the expression that describe the energy conversion. From each of the term, then you go and apply your formula. And when you apply a formula, if you are stuck, that means you should change strategy. Okay, don't anyhow sub the value in. And of course, now I hope you have a better understanding what is work done. It is just energy supply from an external source or energy loss to an external source, like friction, air resistance, this kind of thing. And again, like I said, do not anyhow sub value in when you are stuck. Try a different method.